We're back.
Ohio, yeah, okay. There we are, 3.4, developing and applying the quadratic formula. So, without further ado, here is the quadratic formula. Okay, so it comes from this version of our trinomial with a, b, and c. Notice how it's set equal to 0. So before you use this formula, you need to set your trinomial equal to 0. Okay, otherwise your coefficients will be messed up. And there's the formula in all its glory. There's a plus or minus. Let me show you where it came from very, very briefly. So, there are hopefully 30 seconds or less here, so why don't we do it this way. So we actually just start with our trinomial, ax squared plus bx plus c, and then we're going to divide out the a term. So basically, we're going to try to solve it for x. So the first step would be dividing out the a term. So you're going to get some fractions. Well, there it is. So now you have b over a plus c over a, and you just have the x squared term. Now you're going to move the constant term to the other side. Right, we're just trying to solve for x, so we're trying to isolate it. So we move that over there so it gets a negative. And then we complete the square, because we're not going to be able to factor this very easily. So we actually complete the square. So let's see, that's where we get. Alright, so this is the magic number that we're going to add to both sides, right? We take the b term, which is b over a, divided by 2, which is the same as multiplying by a half and squaring it, and then we add that to both sides. So now you see that popping up right here. Okay, now this will be a perfect square trinomial, so we can factor that. We can factor it. So it's going to be x plus b over 2a, which will be that intermediate step right here, right? B over 2a. Just like I was telling you before. In the meantime, what have we done over here? What else? We factored it. We moved this constant term over to the other side, I think as well. I don't know what happened here. Oh yeah, sorry, my bad. I didn't review this. This is that magic number that we added to both sides, and what's happening is we're getting a common denominator. So this is c over a, and this is 4a squared. So we multiplied this one by 4a to get the same denominator. And then, are you starting to recognize that? If you look back at your formula, it's starting to turn into that, if you look at the numerator, the b squared minus the 4ac. Okay, yeah. And then there's a big plus or minus. So we square root both sides, and that's where that plus or minus is going to come from. Right, so now we have plus or minus the square root of all that stuff. And then we just get the radicand out, which is that. And now we're going to move this to the other side. Okay, and also, well, let's see, let's just do 2 steps. So they simplified inside here. Okay, so they did some simplification, and then eventually at some point this term comes over, so there it is finally, and then they just write it as one big fraction. The square root of 4a squared, so the square root of this is 2a, right? Like, what's the square root of 4? 2. What's the square root of a squared? A. So that's why the square root's only in the numerator. And then there you have it, the quadratic formula.
Wow.
Any questions?
I understood all of it. Thank you.
Yeah, you know what? This might be one of the few derivations that we go through that's like, you can actually follow along if you really, really want to. Just lots of fractions and lots of ABCs. So if it didn't make sense, that's fine. I just want to show you, just want to impart to you the idea that this stuff isn't magic. Like, it came from somewhere. It's not like this magic formula that came down from the sky. Okay? Well, there it is. It's on our formula sheet. You'll want to memorize it if you can. Okay? It'd be a good idea, but it is on your formula sheet. So, let's just do some examples. Oh, this is really similar to the mental math one we did, but we got a different sign here. So, like, how are you going to know that you need to use the quadratic formula? Okay, so if I say solve, and you can't factor it easily, one of your options is the quadratic formula. Okay, or you could complete the square as well, right? Like, let's look at this. Can we factor two numbers that multiply to this and add to positive 4? It's not going to happen. So now you have 2 options. You can complete the square, that'll give you an answer, or you could use the quadratic formula. Okay? But this happens after you've tried all the other options, right? So, try the usual, factoring stuff from that we learned before. Factoring methods. Okay, and then if you can't factor, well, you do this or you do this. Okay? So, I'm going to say let's do the quadratic formula. So it's already set equal to 0. Remember, that needs to be the first thing that happens. And then what I would do is I would just go grab A, B, C. Sometimes by not saying anything, you're just as complicit. So it's, what is it? It's this?
Yeah.
Great. Guys, I love editing my videos. It's so much fun.
Yeah.
Okay, I should have double checked. That's definitely what it is?
Yeah.
Okay. That's what it says in your notes. Who's got the formula sheet? Someone check the formula sheet?
I have this.
Yeah? Okay, just wanted to be double sure. Okay. Alright, well we got all this. It's set equal to 0. And here we go, plugging everything in again. So upset. I'll never forget it again.
I'm gonna hold you.
I guess there's not like a whole bunch of stuff that you have to erase. I just wanted to redo it here. So there's everything being plugged in. So some things will sort of stay the same as what we had before. Let's clean up the square root. So like we have 16, subtract -4, but then it's times -1, so it's add 4, so it's 20. So it's the square root of 20 over 2 times 1, which is 2. Yeah. So now you can leave your answer like that. Like you could plug it into your calculator, or you could reduce it a little bit if you like. I'd be fine if I just said, you know, what's an expression for x? Like this is an expression for x, right? Like you have an answer. Okay, but I don't know if you guys remember. I think we do a whole unit on radicals again. Right, but like you could reduce the square root of 20, right? Like it's 4 times 5, and the square root of 4 is 2, so it's 2 times square root of 5. So yeah, there is some potential to get rid of this division by 2. Okay, so as long as I do it to both terms, it's fine. So I can divide -4 by 2, and that would give me -2. And then this has a coefficient of 2, so 2 divided by 2 is 1. So I just get the square root of 5. So that would be like a fully reduced answer. But this would totally be fine. I'd be okay with that.
Like you would give us full marks if we just put that in.
Yeah, as long as it didn't say like, I don't know, tell it to me to 2 decimals or something like that, yeah. Or like simplify. If it said simplify, you'd have to go to here. Yeah. If it just said solve, well, you solved it, right? Yeah. Not trying to play on words, but that's what it means. Solve means, well, here's a solution. Here's a simplified solution. So if we say simplify, go this far. If I say solve, you could stop there. Unless you had a calculator, then I'd be expecting the decimals, right? But if you didn't, then you'd be good. All right, let's do another one. Enough talk. So, a different one. This one, we might have to do a bit of work to foil it out, I think. So again, you sort of get to a point where you're like, I can't factor this, so I could use a quadratic equation. Like you could use it at any moment, really. You can use it on questions that you can factor. It's just a lot of work. Gonna have to foil this one out, right? Right, because when we use a quadratic equation, it has to be in this format. So it's not equal to 0. We don't even have an x squared yet. So yeah, gotta foil it out. So what we'll do is, well, this is a difference of squares, right? Does everyone agree? Right, so you know that a difference of squares is just going to be, we'll square that one, put a negative sign, and square that one, and you foiled it out, right? Just working backwards from the formula. Then you can distribute the 3 into the brackets, and you can get 3x squared minus 3. And now what do I have to do?
Divide by 2.
Even better, yeah. So like move this term over to that side, right? Like we need to get it equal to 0. So we're almost there. Like we got 2 terms on one side. Let's get that term over there. So I'm going to subtract 2x from both sides. And then I just wrote it in the middle because that's where it belongs. But now I have it in the right format and I can use a quadratic equation. I guess I should check, like, you know, I'm not going to tell you to necessarily use quadratic equation on the test. Like, you'd be trying to factor this, you'd be trying to solve it, so you'd be trying to factor. So in this case, it's a decomp. So you'd be looking for two numbers that multiply to -9 and have to add up to -2, right? And then really quickly, you'll be like, well, my options are 1 and 9. And that's nowhere near 2. What other options do I have? 3 times 3? Right? And like, how are you going to get -2? Like, you can think, imagine playing with the signs. Like, I'm never going to get them to add to -2. So I can't factor. So then it becomes, okay, so I can either complete the square or I can use a quadratic equation. That's how you know. I like to use the quadratic equation. So my A term is 3, my B term is -2, and then my C term is -3. And then write out your equation. Write it out correctly, unlike me last time, like that. You'll know you've done enough homework when you've memorized the equation without trying to memorize it. So I didn't do enough homework before. Okay, but there it is. Now plug everything in. So negative B, so -2 is +2. I usually like to clean that up when I plug it in.
Grade 9 students, W, X, Y, and Z, go to the library.
Nice, we're done with all that. So -2 squared minus 4 times A, which is 3, times C, which is -3. And it's all divided by 2 times A. So that's a good step, so I can see that you sort of knew where everything went. And then you can start reducing stuff down. So I usually like to clean up the square root. Like, I'll go, okay, I got 4, and I might even write it over here. I got 4. Now, -4 times 3 is -12, times -3 again is +36. Do you guys agree? -12 times -3. So I get the square root of 40. I was going to write that. Make that a little bit shorter. Divided by 2 times 3, which is 6. And you could potentially leave the answer there, right? Like, you'd either be plugging it in on your calculator to get 2 answers, or you'd be reducing that square root of 40 to clean it up. So square root of 40, what's 2 numbers that multiply to 40? 4 and 10, perfect. Now 10 is 5 times 2. So I got 4 times 5 times 2. Square root of 4 is 2. Can't reduce that anymore, so you get 2 times the square root of 10. So we could potentially start doing that. I will always try to simplify them. So we get 2 square root 10 over, now 6 is 2 times 3, right? So do you see how there's a common 2 everywhere? Like, this term has a 2, that term has a 2, there's a 2 down there, everything's being multiplied. So you could divide everything by 2, right? So 2 divided by 2 is 1. And then 2 square root 10 divided by 2 is going to be 1 square root 10. So we usually don't write the coefficient, we just write the square root 10. And then 2 divided by 2 is 1 times 3 is 3. So there it is, fully reduced. Okay? Yes, sir.
If you do this on the test, will you get bonus marks?
No.
Dang.
I'm sorry, I wish I could. I wish I could give you guys all a smiley face stamp
Well, you could.
on
You could
every
just put
test.
smiley stickers.
And just be like, you did it. No grade, just like
Oh,
you,
wow.
wrote a test. You did a thing. Here's a smiley face.
Oh, wow.
Yeah. But yeah, like I said, you could just leave it here, unless it says simplify, which there will be a question that says simplify. Okay. Questions? Do another one? I'm gonna erase this. I'm okay to erase it? Alright, you guys are fast today.
You're so smart.
You guys are fast. Okay. Let's see. I think we have like a wordy problem. It's kind of nice to do one because, yeah, there it is. And then that's it. So let's do the wordy problem. Oh my goodness. Now, I wouldn't expect you to remember the formula for the surface area of a cylinder. So that would likely be given, you know. I'll take a read through it. And there's going to be some square roots involved in there somewhere. what the heck is a cylinder? It's like one of these things, like a can.
Yeah, it's like
Yeah.
you can.
Yeah, so like this is the height. You got like your radius, which is right there. Is there anything else? I don't think so. So like your surface area formula was you got two circles. So what's the area of a circle? Like the formula. Pi r squared, and then there's two of them. So there's the top and the bottom. And then people never remember the curved part. Does anyone remember the curved part? Close. If you get a piece of paper, I don't know. I used to do this. Watch magic. Magic happen. So here's a piece of paper. It's a rectangle. Now it's a cylinder. Yeah. Ahoy there, mateys! Yes. So there it is. Now the radius is this dimension here, right? Okay. So when you unfurl the radius, so watch what happens to the circle. The circle that used to be the bottom is actually the length, right? And then this is the height. So a rectangle is length times height. What's the circumference of a circle? Right? That would be the length, right? The length would be the circumference of the circle. So what's the circumference? The formula. It's 2 pi r.
2 pi r.
So that's the length, and then times the height. There's your surface area of a cylinder. Yay! Isn't that neat?
I remember that.
Do you remember that? Did we do that in math class?
I did in a
Yeah.
class.
I used to just give the kids a piece of paper and be like, whoever figures this out gets to go home and have oldest candy. Yeah,
Really? For
people
just
found-
an equation
people-
like that?
Yeah. I'm a nice guy. Okay, let's see. So the surface area of a cylinder is 250. Okay, perfect. So we know this is 250 centimeters cubed, whatever. The height of the cylinder is 7. Okay, so the height is 7. What is the radius of the cylinder to the nearest hundredth of a centimeter? Oh my goodness, that's horrible. So we're looking for r. But in our formula, we have an r and we have an r squared. 2 pi is just a number, right? Like 2 times pi is like 6 point something. 6 point, was it 28 or something? So, okay, so this is just a number. So it's like, okay, so I have this quadratic, right? This is like a x squared plus bx, and then my c term, there is no c term, right? The plus c, there is no constant term. Unless, there's my constant term, it's over there. Perfect. So what can we do? Do you want to factor this thing? With the 2 pi's in it? Do you want to complete the square? Nah. Let's just do the quadratic formula to figure out what r is. Okay, so use. Now instead of writing x, just write r, but it's going to be negative b plus or minus b squared minus 4ac divided by 2a. So I just replaced this. Instead of calling it x, I'm going to call it r, because that's the variable that I got. Now, do I have this thing set equal to 0? No, so that would be maybe one of the first things I should do is, let's get this thing equal to 0. So I'm going to recopy it over here. And I'm going to write 250 equals 2 pi r squared plus 2 pi r times 7, because that was the height. And now I'm going to get this thing equal to 0, and I'm going to clean this up over here. So I'm going to subtract 250 on both sides. The 2 pi I'll just leave as 2 pi. Now, 2 times 7 is 14, so I have 14 pi r, and then subtract 250. There we go. So now I can see, here's my a value is 2 pi, my b value is positive 14, and my c value is negative 250. Now you could go mucking around and plugging in a decimal version of that number, but I would say don't. But it's like it's more writing, and then you have to round and just write 2 times pi. Okay, I know that's a little weird, so our formula is going to look a little funny, but or maybe should we plug in the decimal version? What do you guys want to do? Because we're going to be taking b, which is 14 pi, and then squaring it. I would say leave it. Sure, but you know, you could go write it. You could write it as a decimal. I wouldn't. Watch what happens if we don't. So I'm going to plug in negative b. So I go negative 14 pi plus or minus. Now b is 14 pi squared minus 4 times a, which is 2 pi. And then c, which is negative 250. And that's all divided by 2 times a, so 2 times 2 pi. I know it looks ugly. This is definitely a calculator question. So now I have negative 14 pi plus or minus. So 14 squared is, oh, I can't remember. Is it 220 something? No. 196, thank you. So I get 196 pi squared, right? Pi times pi is pi squared. So that was the part I was worried about that might confuse some people. And then let's see over here, we have 250 times 4. They're both negative, so overall I'm going to get positive. 4 times 250 is 1,000, right? I think? Yeah, okay, so it's 1,000, I do believe. And then times 2, which is 2,000. And then we have this pi that we're not multiplying in yet. There we go. All divided by 2 times 2 pi, so 4 pi. There. And then I would just go to my calculator and plug it in. You know? Maybe like you could write this as an intermediate step, like just to make when you punch it in on your calculator a little less tricky. So I might go figure out like a decimal version of that, which I'll just go grab a calculator and I'll quickly let you guys know what I get. So we got, and if you can't find your pi button, you can just go 3.14 squared. For example, I'm having trouble finding the pi button on here. Here's, come on, every calculator has one. Oh, that's a lie.
Shift and an exponent. Exponent's in the bottom row.
Oh, there it is. You have the same calculator? Nice. I was like, you have very good eyesight. Okay, thanks. So I'm going to go pi squared times 196 plus 2,000 pies. Ooh, delicious. Okay, I got a big number. I got 8. Maybe it's not that big. 8,217.63. See if you can get that. I'm expecting it to be a bit bigger, but that kind of makes sense. That'd be about 6,000. Okay. And then just go pop this in on your calculator. Get 2 values for R. So what I like to do is I'll do the first one, I'll do the plus. I'll go this plus the square root of that divided by 4 pi. So this you should certainly try. So see if you can get this same answer as me. Okay, moment of truth. So I got R equals 3.714, and I guess it would be centimeters, because that was the question. Okay, so check that one, and then I'll do the other one as well. So negative 14 squared, or negative 14 pi, subtract, that's square root 8,217.63. Yeah, you're gonna get a negative answer on this one anyways. So on the other one you get negative 10.7.
If there are any grade 9 students who have not gone to the library for course advising, please go there right away.
Perfect. Okay. Can we have a negative radius? No. So that's an extraneous root, and your only answer, and I don't know if it said to the nearest 100, I did to the nearest 1,000. So 3.71 would be your final answer. There we go. So you guys can do, what is it, exercise 19? Take out your book, and I'll be around to help you. We can do a couple together. Bye-bye.